Let's talk a little bit about oxidative stress and where does it come from? We've got it all around us. What are some of the most common ways people get exposed to oxidative stress?
Well, oxidative stress is just what it says, oxidation. And it's basically rusting. That's a common form of oxidation. It's basically when you're under oxidative stress, your body is rusting. And what does that contribute? Well, you've got proteins, like collagens and just dozens of different types of proteins in your body. And a lot of times they have to move around and they kind of have active motion. And if you get an oxidative event, hits that protein, it can cross links parts of that protein. So it doesn't move the way it should anymore. It doesn't do the function it did. So that you just damage your proteins. And another thing, it can oxidative species can punch holes in your cellular membrane. So things leak out or things leak in that shouldn't be. And usually people can tell that. There's actually aldehyde tests you can take that can tell you the oxidative stress level you're under by the damage to your cellular membranes. And then finally, there's RNA and DNA. Obviously, that's the blueprints of the cells. And if those get damaged, well, then, the cell has a problem rebuilding itself since it's lost its blueprints.
Okay, let's break this down a little bit for our listeners who don't have the advanced chemistry background that you do. So let's talk about exercise. Like how are people getting exposed to oxidative stress through exercise?
Well, 65% of your oxidative stress that your cells are under come from the mitochondria. And if you remember, mitochondria, these little tiny organelles inside your cells, and they're symbiotic organisms kind of that in the cell, and they have their own DNA. And so they make ATP and a bunch of other important molecules that are part of the functioning of a cell. And ATP, of course, is the energy molecule of the cell. So something like 95% of all cellular metabolism is due to ATP. So if your mitochondria aren't working efficiently, then your cellular metabolism can't work efficiently either.
Okay. So if you work out, do you have an increase in oxidative stress?
Oh, yeah. Sometimes if you're really working out, the mitochondria are making ATP, and then ATP, of course, is what's making those muscles move. And so when you're exercising out, you can have like 100-fold increase in oxidative levels.
Okay.
They just come flooding out of the mitochondria. And that's a lot of what people hear of DOMS, delayed onset muscle soreness. A lot of that is due to the oxidative damage that happens when you're doing extreme exercise. And, that just basically there's so much oxidative species, primarily superoxide, which our friend C60 takes care of. And at a very well degree, and it just kind of floods out, does a bunch of damage in your cells and tissues, and then it takes a while to fix that. So when you have C60, the C60 can greatly reduce that oxidative burden and get rid of those superoxides before they cause damage. And so people that take C60 notice a noticeable reduction in recovery rates. Mm-hmm. They go from hours to, they could be 3 or 4 hours to 45 minutes. And also DOMS, which is the pain you feel 2 days after a heavy exercise, that goes down as well.
Okay, cool. What about, let's go back to kind of how you discovered C60 and the oxidative stress that you were concerned about, because you were working on the MOXIE fusion reactor project. This is something that you guys might have heard Ken talk about before, but he doesn't tend to brag about himself because he's pretty humble, but I want to share this with you guys. Ken was pissed off about Fukushima, and he was working to solve a big problem, which was proving a more efficient form of nuclear fusion. So you were going to be exposed to a tremendous amount of radiation potentially in your work, correct?
Yes, and one of the things radiation makes is the hydroxyl radical.
Okay.
And that's basically a water molecule that has the proton tore off.
Okay.
And so it's got this loose electron, and that loose electron can go out and damage things. And usually when oxidative stress happens, there's a cascading effect. Because let's say that hydroxyl ion is going to tear a proton, let's say out of one material, and then that material is now unstable, and it tears another and another. And so you can get this layer line of oxidative damage as one thing follows another. So if you cut it off at the pass, so to speak, you don't get all the downstream stuff. And so the hydroxyl radical, in fact, that's the only two oxidative radicals this guy does. And if you notice inside here, you can kind of see these little white dots. Those are the symbols of hydrogen atoms.
Right here.
Yeah. And C60 is the unique molecule in chemistry because most molecules that like to get a positive charge do so by releasing an electron to the environment. Electrons are negatively charged, and now they have less electrons. So they're positively charged. But C60 doesn't do that. C60 actually pulls positive hydrogen ions from the environment and stores up to 6 of them inside of its cage-like structure. And then let's say like a superoxide comes by. That's basically an oxygen with an extra electron. Well, it's attracted to, because it's negative charge, it's attracted to the positively charged C60. And when it touches that, the C60 will take the electron, releasing the oxygen to go back to become a regular oxygen. And then it takes one of these little hydrogen ions and neutralizes, and basically that gives it to the electron and turns it into hydrogen gas, which is actually another antioxidant and a signaling molecule. So, and then with the hydroxyl ion, it's negatively charged. It touches here, the C60 molecule will release one of these hydrogen ions and turn the hydroxyl ion back into a water molecule. And see, that's the key why C60 is characterized as several hundred times more powerful than conventional antioxidants, because it can reset itself again and again and again. And like normally, like the hydroxyl ion, glutathione takes care of that.
Okay.
And glutathione has a lot of jobs besides that. So, but when you have a heavy radiation, it'll just use up all your glutathione. And but C60 will take care of that. And so your glutathione can do its other jobs. That's why it's such a super radiation protectant. But let's say when glutathione does get an oxidative radical, like a hydroxyl radical, it'll change its physical shape. And actually your body has to use some ATP molecules and some enzymes to reset glutathione. So it has to reset itself, but it takes body chemistry. The thing about C60 can reset itself all on its own. It doesn't need any ATP. It just does it by itself. And that's really the secret behind C60, its ability to reset itself again and again and again every time it neutralizes an oxidative radical.